Welcome to On Rails, the podcast where we dig into the technical decisions behind building and maintaining production Ruby on Rails apps. I'm your host, Robby Russell. On this episode, I'm joined by Miguel Conde and Peter Compernolle from Gusto, where both play pivotal roles in the company's architectural evolution. Miguel leads efforts to extract the time product, covering time off, scheduling, and time tracking from Gusto's massive Rails monolith. Peter is the architectural lead for the company's benefits domain, a codebase that's been separate from the main app for years due to HIPAA compliance. Together, they sit on Gusto's architectural council and bring unique perspectives from working on two very different yet equally complex Rails applications. This conversation will explore what it takes to untangle large codebases, make Rails work at scale, and find the right balance between convention and customization. All right, check for your belongings. All aboard. Peter and Miguel, welcome to On Rails.
Thank you very much.
Thank you for having us.
So I want to start with a kind of a simple question, I think. Let's start with you, Miguel. What keeps you on Rails?
I like the speed of Rails, especially coming from a Java world. Rails unlocks a lot of speed and development, especially in this day and age where we have such new technologies and AI and things are evolving quicker than ever. The speed that Rails provides allows companies to unlock new capabilities faster than, say, a strongly typed, very methodical language like Java or C#.
What about you, Peter?
I think that's a good question. I really like how quick it is to prototype in Ruby on Rails. The way that I think is usually by putting my ideas in code and then seeing how it feels. And with Rails, you can do that really quickly. And then with some of the more recent tooling, you can get some benefits that feel like a compiler. So you get kind of the best of both.
Interesting. We'll probably touch on a couple of these topics throughout the conversation, but one of the reasons I really wanted to have you both on this show, so you both work at Gusto, and I mentioned in the intro approximately how large the engineering team is there, but how long have you both been at Gusto at this point?
I've been at Gusto going on 7 years, so a little more than 6.5. I've been on the benefits team since day one. At the time, there were 12 engineers on benefits. Now there are over 60, so we've grown quite a bit.
I have been at Gusto, I guess, hit my 4-year mark last month. I have been primarily on the times team. That team, when I joined, was about 4 engineers. We are up to 16 now.
We'll definitely dig into what those different sides of the organization there make, what is involved in there. Peter, can you help paint a picture of Gusto's, I'm going to say, Biolith setup and how benefits ended up as its own Rails application?
So, like you said, we have a Biolith.
What does that mean?
So instead of one monolith, we have 2 monoliths. And big picture, we have, let's say, 80% of our engineers, 80% of our code, 80% of our product in one monolith. And then we have just under 20% in a different monolith. And so that second one was split out before my time for HIPAA compliance reasons. So all of our PHI, or personal health information, is stored separately from our main application. So at the time, it was really just for HIPAA compliance reasons. And over time, that's been one of the best or luckiest decisions that I've inherited, because we have a smaller application to work with, which is a lot easier to move quickly than a very large application.
You know, something that makes me curious about, I'm just assuming if I was going to work at a brand new startup and we're going to be like, we're building an HR platform, maybe you might describe it more than maybe an HR platform, but that's how I think about it as a customer of Gusto for my company. But I would just think like, well, the whole thing has a lot of private information. Where does that boundary lie? I guess there's the HIPAA stuff when it comes to like healthcare related things, but I'm like, where's that distinction where it's all very, very private information about employee information and records about employees? And so is there a lot of difference in compliance from that part of the application that's more like HR related employee stuff versus the HIPAA thing? And you're like, we need to segment that off. How is that not just already thinking, just apply the same sort of rules to the whole thing?
That's a great question. So I think this has evolved over time. Now we're very sensitive to compliance, but at the time, it was simpler. So the main reason this was built separate was partially so we could have a second data store. And at the time, Rails didn't handle multiple data stores. But also the application is only accessible from the other side of the firewall. So all of our benefits related admin functionality, you can't even access from the outside world if you tried. And that way we could be very explicit and careful about our APIs and how that data was shared, because by default, it was inaccessible to everybody. And we had to be explicit and go out of our way to make it accessible to anybody.
Do they interact much with each other?
So that's another thing that's changed over time. At the moment, the only interaction really that we have with the main monolith is when we are sending information to the front end for our end users, our customers. Um, Over the years, we've reduced that communication quite a bit, but it used to be a little more of a circular dependency. So our primary customers, the way that we think of them are, there are companies or employers and employees. So those are the two different ways most people interact with Gusto. And we used to sync that data between the two applications all the time. And now we've become much more intentional about what does the benefits product need, and we don't want any more. We lean heavily into eventual consistency so we don't have runtime dependencies. I can go into a lot more detail, but suffice to say, over the last 5 or so years, we've gone from a pretty tightly coupled pair of applications to a very, very loosely coupled pair of applications.
Just as a end user of Gusto, so is it a safe assumption that if I'm interacting with like the web app and I'm looking at my employee version of my, I'm an employer, but I'm also an employee. So I switch over to being an employee and I'm looking at some of my healthcare related details. Is that then interacting directly with that backend, the HIPAA compliance platform? And it just happens to be displaying that information in the same, it's rendering out, but the other app doesn't really know what's being shared with me. Is that kind of like a dumb way of thinking about that?
So I think I can answer the question by explaining the interaction. So our older code, whether you're an employer or an employee, would ask the main monolith for some data, and then that would authenticate and then basically proxy the request over to our behind the firewall app. So that was a really simple way for us to be confident that nobody was accessing this data unless they were already validated in some way. Over the years, we've moved much of that to GraphQL. So now the front end doesn't need to think so much about where am I getting this data from. We can auth in pretty robust ways using GraphQL. But I think to answer your question, the front end right now is hosted by the main application. It just gets its data for benefit specific things from the benefits application.
That's fascinating. Miguel, what's it like working on the larger monolith by comparison?
It's more fun, but it is definitely a bit slower. We, I think, double the size of HI at this point. You have to be very careful when you're modifying something because everything is so coupled with each, because this is an 11, if not 12-year-old app that was just built on top of each other. So we have a lot of coupling between what we would call services. So when you make a change, you have to be extremely careful that your change doesn't have unknown propagations and you cause side effects, which could bring the monolith down. So there is that. Alongside that, there is also a slower build code to deploy because our deployment CI/CD pipeline essentially has to build this entire monolith, run all the suites, make sure that everything's okay. And then at that point, you go live. If there's an incident or someone's putting out a fire and deploys are blocked, even if your service is not affected in any way, shape, or form, you cannot deploy any code because the entire pipeline is shut down for the monolith while this alert gets resolved.
That sounds like a challenging space to be in. And in preparing for this conversation, Miguel, you mentioned that you're like in the process of say, I think extracting the time, like, is that, maybe you can tell us a little bit about what you mean by time product from the main monolith?
There is an idea that, okay, all these pain points are felt by every team. If we consider every system as a service, you have time tracking, scheduling, time off, you have payroll, you can name them. We decided that we're going to analyze what systems we can, split up to be atomic units that work well. We're not going microservices where every system is very precise in what it does. It's more like a smaller, robust ecosystem that can operate in a silo almost. So scheduling, which is the team, which is a pod in time, was chosen to kind of lead this effort. And the idea is that all of the pain points that I just described in the build, in the worry that you might be coupled to something and have propagating effect, gets reduced, and you unlock the speed of Rails that we discussed earlier, instead of being bogged down by the maintenance and overhead of a huge monolith.
How do you decide where the boundaries are when you see that there's a lot of overlapping in the coupling?
That is a good question. And I think it's something of an art that we're still perfecting. For scheduling, it was pretty simple. We were a newer feature in Gusto, so it was kind of built in isolation. But one of the key things that I look for, and this is me personally, is essentially, do I have any piece of code that my system needs in order to operate? Meaning, if I don't have it immediately, and meaning it cannot support eventual consistency, then it's probably an integral part of the system and it should be brought into the fold. If these are just side effects and stuff like that, then those boundaries that can be a separate system. So when we kind of carved out what the time systems would be, we carved out 3 distinct ones: scheduling, time tracking, and time off, because all of those can operate independent of each other. They have a lot of intertwined communications, but none of them are necessary for the system to operate as a whole.
And what role has Packwerk played in helping you set those boundaries?
Packwerk has been very useful in analyzing external dependencies. So Packwerk, one, it helped us isolate the code better as we were working within the monolith to make sure that we're not calling into a model that doesn't belong to us. We're not calling a private method that we shouldn't have access to. So it helped in the creation of scheduling to be as isolated as possible. And now it's helping us with a list of public APIs, public Ruby APIs, that we now have to transform into either Kafka or GraphQL by essentially not allowing any outbound calls from our pack. Then we can, start winding down the list from there. It helped in the creation by isolating, and now with detection.
So I think there are some good things and bad things about Packwerk when we're trying to identify these boundaries. So I should start by saying my single most important goal for my time at Gusto, and while I'm still here, is to figure out what these boundaries are on benefits. And so over the years, we've tried different things. The first thing that we tried was extracting leaf nodes to gems. So anything we identified as having really no dependencies, ideally no persistence, really clear logical APIs or boundaries, we moved into gems. And that worked really well because really Ruby has, I think, one fatal flaw, and that is by default, everything in Ruby is public, rather than a language where it defaults to private, and then you need to explicitly say this is part of my public API. So we had years of these unintentionally public APIs, and by moving things into a gem, it becomes a lot clearer what are we actually using and what are we actually depending on. And then Packwerk kind of brings that to the surface so we can see how are things being used unintentionally or intentionally. I should also say I was initially a big dissenter of using Packwerk because at the time I was a little bit of a purist, and I thought that moving things to gems allow us to have technical constraints rather than tooling level constraints. So rather than something at CI or build time saying, you're using a constant you shouldn't. Well, if it's in a gem, you have complete control. Your gem runs its own tests. It doesn't bootstrap the monolith. You have to be very intentional about that. But something changed that I think made Packwerk at least 10 times more valuable in figuring this stuff out. And that was when we introduced Sorbet. So Sorbet, if you've never used it, is kind of a typing system. It's a way to take an untyped Ruby method and you can say, you can define a signature. So, okay, we can talk about Sorbet's pros and cons, but what really enhances Packwerk with Sorbet is you're required to say the type in the signature, whether the arguments or the return value. And so if your method before had a variable and the method contents didn't change or declare the constant or the type, you had no idea what that method was using or depending on. But when you introduce Sorbet, you're forced to say this is taking an instance of such and such class. And this class is defined over there. And based on our rules, we've decided we don't want that relationship. So doing that, I think Packwerk changed everything once we introduced Sorbet. A colleague of mine described it as it's like we had a huge mountain of dirt and we bulldozed big hills from the dirt. So we weren't exactly sure what the boundaries were, but we could see where there was a lot of signal, where there's smoke, there's fire. So we could see this is like a hot spot and we can dig deeper into it. And I think that was really a combination of Packwerk and Sorbet helping us do that.
I'm really curious about, when I talk to teams like at your scale where you're seeing the benefits of using something like Sorbet, and that's not like the default way like a lot of Rails developers would think about these things. So I think some people might be curious, be like, well, what sort of problems were you really having if you're like, well, we pass in this method, we're passing something to a method and it's the wrong type of thing. You would figure that out because something would break, right? Or your tests would help capture that. Or like, is it just at a certain scale of like a certain volume of engineers and not everybody's going to understand things? Like, can you describe maybe some of the problems that you were having? You had that mountain of a mess of dirt. Like, what was that like?
I think there are two reasons this before was a big problem for us. The scale of the application, just the size, and also how old it is. So a lot of our job is code archaeology. It's going back in time to understand why somebody built something the way they did. So that's the age of the application. So there might be a variable name that in its original commit made perfect sense. And then 4 years later, somebody changed something such that that variable could be one of two things. I don't know, something like that. And that means that now, 5 years after that, I'm looking at a method with a variable name that is misleading. And you can dig up the stack or go down the stack and make sense of what it is, but that takes time, which now plays into the scale. So if we want to refactor anything, you need to know what is using that thing. And the more decoupled we get, the more we isolate things, the more we make things private, the easier this becomes. But in the meantime, we have to know all of the callers of this method or all of the consumers of this constant. And if it's just being passed around as variables, or if there's even a hint of metaprogramming, that can be very risky. And so the beauty of Sorbet in this case is you can remove a method and in an instant, just like people working in a compiled language, you can see 17 different places that are calling it and tests that are doing this with it or whatever. And Sorbet makes that a whole lot easier.
If someone listening were to be curious about like implementing something like Sorbet, is that something that they would need to do all encompassing? Like, does the whole application need to be sorbet or however the the verb of that might be? But or can you like introduce this like in certain areas of your code base? Like, hey, like this is a really delicate part of the system. Let's apply some of the signatures around this part of the application to help protect that, or you have to kind of think about it on a macro level.
You can do it gradually, which is the whole design. So you can declare per file how strongly typed you want it to be. So you can say, I want Sorbet to ignore this code entirely. You can say, I don't want Sorbet to type it, but it knows about the code. You can have true where it allows some flexibility or strict where there's no flexibility. And this is the only reason we were able to use Sorbet because our application is just too big. So we could do this gradually, hotspots first. But I will say that in the beginning, this is useful as documentation, but little more, because documentation we all know can be out of date or inaccurate. And early days Sorbet signatures, we might be making a best guess, like something is coming from HTTP and it's an integer. So we type it as such, but then it turns out in some contexts, it's a string. So we can learn that and log it in production, and we get a little benefit. But it can be risky because if we trust that it's an integer too much and then we add to it, then we can have issues. And so there's sort of a tipping point where after we get to a certain point, we can start to trust it. And we know that it's not 100%. It's not a compiler. But we can start to look at a signature and be pretty confident that signature will be right. So I don't need to look at the implementation of the method or validate the callers. And ultimately, that's what this is for. It's to allow us to move faster. So we don't need to understand the entire application to make any change. We just look at a signature.
Miguel, I'm curious. You both mentioned this, I think, already. Can you go back to something you mentioned? You said eventual consistency. What do you mean by that?
Within Gusto right now, we have a lot of asynchronous processes. So one of the things, and this is something that the app, its age shows in Rails land, if I make a change to a model or something and I have 10 different services listening in on it, there are many ways to do that. You could either do, a sequential and make sure that every service updates, and that works at a, maybe small, medium scale. But at a large scale, or when you have multiple data stores, you cannot guarantee transactions. So you don't have that atomicity. Eventually, the system will come into consistency across all of our services. So we have an inventing structure that you can hook up to. Right now, it's being powered by an internal implementation, but it's slowly being replaced by Kafka. That when something happens, a pack or service will emit an event that says, I have made some change. And then any consumers that are interested in that can update their tables as need be. The only thing is there's no guarantee when that message arrives to us. It could be almost immediately, or there can be some lag. So that is what eventual consistency means.
That's interesting. Yeah, I don't know that I've heard that term before, so I was kind of curious about that. Diving back a little bit into the Sorbet and Packwerk, are there any boundaries you've had to enforce that Rails didn't quite give you by default?
Yes. So one of the major kind of like pain points in a monolith with Rails is that everything as you pass it around is inherently mutable. So if I pass around a model and 5 services down, someone decides to update that model or update the object and I'm not aware of it, and then I say hit save, that is problematic because I lose control of my own data store. So one of the things that we did that Sorbet empowers is that we now have structs, which are inherently immutable. So with Sorbet and Packwerk, what we did is we created a repository service API layer where the only interaction with our system or any of our models is through our services. We have the type signature. We return a structure that is immutable. And if you want to make any modifications to our systems or get any data from our systems, you must go through our service layer. We cannot enforce strict privacy, but this is where Sorbet and Packwerk comes in because we can check to see, is anyone not adhering to our pattern? Is someone bypassing us and going, you know what? I'm going to call your model directly and do what I want with it. That's where I think the two systems come into play.
Could you tell us a little bit about that service layer, or how are you mentioned sounds like you might be using gems. Are you using like Rails engines at all in this process as well, or?
No, it's just a pattern. It's a coding pattern. You see it a lot in other like Java, C#. So the repository layer in this case would be the application record, and that's what interacts with the database. And the service layer is essentially where all business logic lives. One of the methodologies that the time teams has kind of like adopted is that we keep the application record layer as dumb as possible. All business logic and all interactions with any external dependencies live strictly in our service layer. So if we're making an outbound call somewhere, that is in the service layer. If we're emitting an event, that is in the service layer. So when you go to the model, there might be some helper functions or transformative logic, but it is these APIs that those are essentially our public APIs that we expose to everyone that says, get schedule, modify schedule, do this, do that, but it's tightly controlled. So we know exactly what functionalities we are exposing and what functionalities we want to remain hidden.
For myself and listeners, can you kind of describe what that directory structure kind of looks like at a high level? Where's your service layer kind of sit in a Rails app?
It would be at the service. So we have essentially our models, which is, it looks very similar to any Rails app, but essentially, so you have the models, you have the service, and that's where all of our service code lives. Our libs would be essentially like rake tasks or anything that are internal that no one's going to call into our library folder. Those are internal tools. And then we have our GraphQL layer. So if you think of a flow, once we're extracted, this isn't how it works right now, but essentially our GraphQL layer will be the interface for interactions to our service. That level is very dumb as well. It just does some basic authorization as well as transforming the network call into, the signature that the service expects. It goes into the service layer. And then at that point, all business logic occurs and stuff like that. And if we need to make any save to the database or modify the database, we call the application record. So, and then the application record deals with the actual database interaction.
Another thing I wanted to mention, and this comes back to what I was saying before about Ruby being public by default. By default, an active record model has something like 350 methods, and that's not including specific accessors added per column. And so a big effort we've undertaken over the last few years is to reduce the size, the footprint of a single model. And so Miguel mentioned we use Sorbet structs, for example. So this can be a public API. We say, my return value for these APIs is a domain-driven struct, and it is immutable, and only I can instantiate it, I being the service. But another thing we've done is make active record models private. So this is unfortunately a binary thing. You have to work to make sure nobody is using it. There are no other consumers of the model, but for new models especially, we make it private by default. By convention, we usually suffix the model name with record. So instead of a policy, we have a policy record. And this is private to its owning namespace. And that means that anytime some other system needs that data, they can't access the model. So that means we need to expose it via some API. And when we do that, we're confident that nobody's writing to it, whether intentionally or accidentally. And as a tool we've built to get us there gradually, this is open sourced, by the way, at Rails at Scale. We call it Explicit Active Record. And so Explicit Active Record is a concern or a module that you can include in your model, and it will raise an error if you try to write the record in any way. And so the only way you can do that is by saying, my constant with explicit persistence, then you pass in the instance, and then it just does some simple instance variable stuff under the hood to make sure you're allowed. But what's beautiful about this is, one, people don't accidentally write this, so that's good. And two, we can grep or search the code base for anything that is writing this model. And this is particularly valuable for really old legacy models that are distributed across the application. So we can see all, 12 places where we're modifying this. We can use that information to strangle it and bring it into a service class like Miguel is describing. And then suddenly we have pretty high confidence that the only thing that is able to change this record is here. And therefore we can refactor it or, evolve it in any way that we need to.
I think a real concise way to put it is Sorbet unlocks or makes it much easier to do object-oriented programming within Rails. If you want to use object-oriented programming and take use of encapsulation, inheritance, everything that entails, Sorbet is your friend. If not, it's not as useful.
So you mentioned is that explicit AR or active record? That's just like a gem that teams can install or something?
Yeah, it's really simple. So the idea is you call a static method and you pass in instances that are allowed to change. And then that keeps track of them in a private internal store. And then when you call save, it checks to make sure that you're allowed to change it. So it's really simple. It's more a pattern that's useful. But over the years, I've become very, very dependent on searching for with explicit persistence for, because then I can be confident nobody else is changing this.
I'm just looking up the README now and that up here on GitHub. So I'll definitely include links to that in the show notes for everybody as well. Are there other tools that your team has built to kind of help optimize things around defining boundaries or making Rails more object-oriented?
There's one that I love, and it's a little hard to explain. This, unfortunately, is not open source, but it's really just a pattern again. So in Hawaiian Ice, that's the application used for managing benefits. We use this pattern all the time. We call it published model builders. And so part of this is we have a few models. We call them God models. So these are models that over the year have just become super bloated. They're just very, very big models and hard to work with. And so if you mix in the fact that they're very big, it's unclear what their purpose is, and we don't have control over the rights unless we're using something like explicit persistence, we've defined a structure that takes an instance of an active record model but cherry picks specific attributes from it and then builds a read-only struct. I don't know if I explained that well, but what's cool about this is consumers of this model can define which attributes they need by defining their own struct as a subclass of this thing. And then they include certain modules. And then the owner, the owning pack of the model, gets to decide which attributes to expose using this pattern. And so from that, we get two really cool things. One is we're guaranteed that these models aren't being written to by a consumer because we aren't exposing those methods. And two, because you need to include modules to describe which attributes you want, we're beginning to understand how we might decompose the model into smaller models per concern. So if you have 15 different attributes, you can maybe break them down into 3 groups of 5. For example, if you have an employee, so an employee is one of our bloated models, you can define a module called employee demographics. And maybe this includes first name, last name, birthday, maybe it includes address. And then there's another module that's, let's say, dependents. So in benefits, we deal with dependents. And that means that as a consumer, if I only need to know a first name, I include the employee demographics, but I don't include the dependents. And so from that, because it's Sorbet friendly and because we've defined this with Packwerk in mind, we can use those tools to gather, oh, this is what is being used across the board. This is only used by this one pack. So maybe that can make a different model and synchronize that data somehow. So it works well at constraining everything so we don't make things worse, while also teaching us a little bit about how the application is behaving.
Yeah, no, one of the gems that has really helped us do this encapsulation and keep the logic in the service and try to keep the active record model as lean as possible is after commit everywhere. And this is a nifty little gem because this ties into eventual consistency. Let me give you a scenario. I have a service that I modify 3 tables, and at the end of this transaction, I want to emit an event. And this event goes out and says, I have changed my data store in some way. I can guarantee within my method that I complete my own transaction. What I cannot guarantee within a monolith is that someone is calling my method within a parent transaction. So if they decide to roll back the parent transaction, my transactions are also rolled back as well. This is where after commit everywhere shines, because instead of me having to put the logic in after commit and only be able to do it at the model layer, what after commit does is that it checks if it's in a transactional state. And if it is, it actually queues whatever you put in the block to only execute after a full transaction commit. If it rolls back, then none of the code within that block statement gets executed.
That's interesting. I was just pulling that up. Looks like also that's might be created by our good friends over at Evil Martians.
Sidekick uses this under the hood as well. A year ago or so, they introduced a new API called transactional push. So if you enable transactional push under the hood, it uses after commit everywhere. One problem we've had with this is in Hawaiian Ice, we have 2 different databases, and after commit everywhere has a little support for multiple databases, but Sidekick doesn't make use of it. So we have to think, which database do I want to commit and which do I not care about?
One of the things that you were talking about there was like that those examples of those God objects and things get really big. And you brought up like the employee model is getting really big. Maybe there's a lot of attributes in that. I'm assuming you're in your database table for that one. How often does your team think about going back and trying to break those up into smaller? Not just is it just the models, or also the models and the tables themselves? And where's that trade-off?
All the time. All the time. I think that's something we're frequently thinking about. We talked earlier about identifying boundaries. One of our biggest challenges is we've all been trained to think about normalized databases and what is a reference and what isn't. But as we've gotten smarter about our boundaries, now we start thinking a little bit more about snapshots. So this data, maybe the service only cares about what the data was when this method was called. So an example, I'll use an employee as an example. If an employee signs up for benefits and then we submit that information to the carrier, the benefits carrier, that process might take 2 or 3 months. So in the beginning, if the employee signs up for something and then we submit, if we only store an employee ID to look up the demographic information, then it becomes ambiguous at best what demographic information we submitted to the carrier because it might have changed over those 3 months. Demographics is maybe an extreme example. People don't change their name very often, though they might. But something like an address is actually very important. So if someone changes their address before we've submitted it, great. We make sure they're still eligible for that coverage because maybe they change states or something. But if they change their address after they submit it, well, now we need to submit that new information to the carrier. So it's forced us to rethink a lot of our old best practices. And now we're working really hard at denormalizing things and being very mindful. Does this fit in one table? Or is this maybe multiple records that are effective dated? Or do we split it across tables or domains?
I would imagine with that type of data, you're having to track the changes of all that information, right? And so like even in that particular example of like, well, you've submitted for healthcare to get healthcare coverage or something and to a carrier, and maybe that person gets married, all of a sudden, like maybe they want to include their partner or not, or but their status, even their tax details might need to change at that point. They want to start filing differently for payroll. There's a lot of versioning, it sounds like, happening behind the scenes as well. So it wasn't a topic that I was thinking of planning about digging into, but while we're here, are there tools out there in the ecosystem that you're able to leverage to help you manage some of that kind of data persistence and evolution, or have you just had to get really creative on your own there at Gusto?
This might not be an answer that people want to hear, but I don't think it's a problem solved with tooling. So we use Paper Trail. Paper Trail doesn't work particularly well at scale to run the application. So it's good for audit trails. It's not great for checking what was the data as of this time. But mostly it's understanding what information does this function need. So we've gotten much better about it as we've defined these boundaries. It's really I think a very fun problem to work on in benefits, because if you look at the schema, it could make perfect sense. We have a very well-defined schema. But then if you add the dimension of time to it, that open enrollment window might take a month or more, and then submission takes time after that. And then you go a year, maybe nothing changes in that year, maybe it does. Suddenly the schema, you need to add that other dimension of what is it at certain points in time when it's being used. I'm getting excited now thinking about it because it's such a fun problem to solve. And we have a pretty solid foundation. And so it requires rethinking kind of with low stakes. It's fun.
Yeah, from time side, everything in our system is a timeline. So all of our tables are actually temporal in nature, and some of our tables are bi-temporal. So not only do we answer the question sometimes, what was this at this given point? We also ask the question, what was this at this point? Also, what did the system think it was at this point? So what that unlocks is you can retroactively change something, and we can tell you before this date, it was this, but now someone went into the system and changed it, like 3 days back to like now be this. So we can answer that question. And it's very important for auditing, especially when it comes to timesheets, because someone can argue, hey, my timesheet was not this 3 days ago. And we can clearly answer that question in our own system and say, here you go, this is what occurred.
How do you do that? Are you storing two timestamps on a row? Like one is the date that it was supposed to be effective, and one is the date that it was actually effective?
Exactly. We have a effective start and end, and then a version start and end, where effective says this is when this takes hold, and then the version is essentially the system recognizing what the state of the world truly is.
It's fascinating because as a user of as an employer and say approving PTO as an example, right? Someone might schedule time off for PTO and they have enough PTO available. And because we don't give unlimited PTO at our company. So it's just like, well, you have this much available, you've planned that. And then maybe then there's a change and they need to take some other time off for whatever before that happened. And then all of a sudden that data is, it's just ends up getting, it's like, I can understand how it could be a really complicated thing to wrap around. Like, well, how do you display how much is available at all time when at the point it was approved, but now, since you had to take those couple extra days off and that in between, you're going to have less PTO available than you thought you did at the end, even though that was what it was at the time. And it sounds messy.
What makes that a lot easier is if you're writing that data in one place, because then you can be really explicit. Oh, I need to change some validation. So just coming full circle, if that writing is happening in multiple places, it becomes very difficult to prevent stuff. So the tendency, I think, with Active Record is to add validations to say, look up all the other records and make sure this is good. But if you've invalidated old records, you might not know about that. So having a service class or one place that isolates all of the rights, then now you at least can figure out how to move forward.
When you're building apps like this, where you're having to think about these other dimensions, how complicated is like the rendering, the views to handle if you're now displaying some data that you didn't have or is a different type of, or maybe it's you have data now but like maybe that you didn't have in the past. Are there weird edge cases in the views themselves to try to handle these types of scenarios, or can you decouple that a little bit from the views and just render out what it is? There's a lot of edge cases written in conditionals in your views.
There are edge cases, especially in time when we are temporal, because not all of our data is denormalized. We only denormalize the data sets that we require to work. However, especially with GraphQL, everything, the UI kind of is the combinator of everything. So it may fetch data from scheduling, but let's say that you were scheduled with a job, right? Or a department. Department is a good one. What occurs is if department, we might have an ID reference to a department, but we cannot guarantee that department, which lives outside of the time domain, is effectively dated. So we might be effectively dated, but you fetch this data point using GraphQL. So now it's resolved by another subgraph, call it the department subgraph. And it says, oh yeah, your department was always, I don't know, name your department, Rails Inc. When in actuality, what happened was that 3 days ago, someone changed the department name, but instead of that being a new record that's effectively dated, that system overrode that record. So now it has the same ID, and it seemed from there that it was always the case. So the UI poses that because while the service may be tolerant to eventual consistency or might be versioned, the UI that brings all of these pieces together may not. And that tends to be a very prominent point of failure because it's bringing, all data to service a page.
This episode of On Rails is brought to you by Unsafe Save,
Trademark.
the fastest way to skip validations and write questionable data with confidence. Are you tired of pesky validations getting in the way of your momentum? Just add validate false, and boom, your record is saved. Empty fields? No problem. Missing associations? Who cares? But wait, there's more. Act now and we'll throw an update column totally free. Skip validations and callbacks. That's right, bypass your business logic entirely. Update your database like no one's watching. Why wait for your code to behave when you can just skip the parts you don't care about? Unsafe save, because sometimes you just need that record in the database, consequences pending. Miguel and Peter, I really appreciate you diving into the weeds here for us. And I'm sure listeners are probably like, okay, that sounds complicated, and trying to wrap their head in. And some of them probably have very similar things that they're dealing with as well. And so, obviously we'll help provide introductions or whatever. Anybody ever wants to try to like talk shop with you. But One of the other topics I really wanted to dig into with you at Gusto is can you remind me approximately how many engineers are typically working on either of the bioliths on a regular basis?
I think we're up to 600 something. So it's a lot.
First name basis.
Not quite. I think leading up to this, I've been thinking about what is working well for us with Rails and what is not working well. And time and again, it comes back to how our organization operates. One of the beautiful things about Packwerk is we can be explicit about who owns certain packs. And then each owning team can decide how strict they want to be about contributions. So, for example, we can require an owner to approve a pull request or two non-owners to approve, or we can say you can only make a change if an owner approves, for example. And so now, how many people work in Hawaiian Ice? For years, when I started on benefits, it was 10 or 15. So it was very first name basis. I was even aware almost of every pull request that was submitted and merged. But now we've had to really change how we think about that. What does it mean to own code, really? Do we want to slow people down if they're willing to help us? In some cases. Yeah, I forgot your question a little bit, but I think org structure and software structure, Conway's law really plays a big role at our size.
Can you tell us a little bit about Gusto's air quoting company pull system for local development? I'm finding that I want to talk with a lot of larger organizations. Like, how do you think about as a developer showing up to work at Gusto? What's that experience like for being able to like get something up and running enough that they can start making some valuable contributions? But that relies on a lot of at a scale of this size of this big of an application. How do you have enough seed data or what have you to be able to like interact with something, presumably, and on your local laptop environment or something?
We have two ways to help with development, not including factories. So we use factory bot in tests, but not including factories, we have two ways really. One we call demo scenarios. So this is useful for a number of reasons, but generally speaking, we write a whole bunch of code to say build a universe to verify or demo some feature. So we can spin up an ephemeral environment internally, and that way our product partners or designers can see what it looks like before we ship it to production. And that effectively, like I said, we just write tons of code to build up the environment. That's demo scenarios. The other one we call company pull. So I mentioned before, our main, like the root node for most of our data is a company. So a company has many employees, they run payroll, they have benefits, etc. And a lot of times when we're developing, we need to know, will this work for companies in certain situations? Because the shape of all of our hundreds of thousands of customers is very, very different. Some companies have 100 employees, some companies have one. And so being able to test this out with real world-ish data is very valuable. So company pull is a system we've built internally that scrubs our data of anything sensitive whatsoever, but keeps that shape. So if you have 3 employees, you can identify the company, and this system, being compliant and everything, so it runs in production so the data never leaves, it will scrub all sensitive data and give you a company with 3 employees. Those employees are all named something static, so it's very clear that this isn't real data. It's extremely powerful. Sometimes it's not perfect. Like if we're debugging a production issue with encoding, for example, since we're scrubbing data, we lose that encoding problem. Or if something is date specific, we scrub birthdays, so we lose birthdays. But generally speaking, this is extremely powerful to give us realistic data that we can poke around with.
When you're scrubbing things like a birthday, are you swapping it out with other birthdays then, at least?
Yeah, so the way this all works is anytime you add a column or a table with columns, you're required by CI, so our continuous integration will prevent moving forward unless you do this. You have to define, is this column sensitive or not? And if it is sensitive, you define how to sanitize it. By default, it just comes up with, if it's a string column, it just uses a bogus string. If it's a date, it uses a bogus date. But you can write custom ones to say a social security number is always in this format. And so it can be a little bit realistic. Well, anytime you make a change to this, we run it by legal and compliance to make sure that we are understanding what is sensitive, particularly on benefits, because we care a lot about being HIPAA compliant. But yeah, so it's custom. So you can look at realistic data. It's not always Acme Co. for the company name, but it's close.
I'm curious about like the identification of a person, let's say me, by a social security number. Is it remotely possible for anyone with access to the database to see all the different places I worked at?
No, and that's again really important for us. The best you can do with identification is something like the number of employees, which isn't very useful given our scale. We take extra safeguards. For example, in our data warehouse, anything that is subject to HIPAA has one way of identifying employees, and then anything else is identifies the same employee differently. So we have three ways of identifying companies. We have three ways of identifying employees, and we choose those identifiers based on the sensitivity or the access controls. Just because we really don't want to slip up on this, go to the extreme.
That makes a lot of sense. Yeah, I'm just kind of always curious about things like that at that sort of scale. I'm like, imagine that Gusto has a lot of data that could be really valuable in the wrong hands. And, just trying to think like how do you protect that type of information and make it just like impossible to some extent to do that type of thing. So you mentioned having you have your data scrubbers be able to have these kind of snapshots that people can get access to. And is that something that are you able to get that down to a small enough thing that it's is able to run on your local environment, or is your developers connecting to you have your local sometimes local databases, or are you needing to connect to like a some cloud-based database somewhere that you're running?
For the most part, we do all local development locally.
Okay.
So our local environments are not exactly production environments. So there are little differences. Over the years, we've gotten a lot better. But because they're big Rails monoliths with lots of gem dependencies, it requires lots of resources. And we found the best way to do that for now is just to run it locally. And so when we do this company pull process, we limit it to 25 companies, I think, but that's enough to make sure what we're building makes sense. And then if we're testing something specific like pagination or will this work for big companies, then we have demo scenarios that we can run locally to seed, 1,000-person company just to make sure.
Miguel, how do you see local development changing as like say with your extraction type progress? Is that when you're extracting things, does that end up impacting things like that very often?
It does. So one of the main assumptions that company pool had when it was first created was that we would have a singular database, a singular data store. This is no longer true, and it will not be true. So we're approaching this in two folds. One, we have to solve the problem of how do we pool data from multiple data stores. That's currently being worked on right now. And then there's a harder problem, and it's slightly different, is that now, because one of the way that it works is there's a lot of Ruby code which uses models. So it maps the data to the models and you tell it like associations. But how does this work in a separate service? Meaning, let's say I have an association to an employee in scheduling, but the service itself has no idea what an employee is, nor does it have a model that company pool can use to create employees locally. So that second problem is still being solved for right now, and it probably will change fundamentally how teams use company pool when they just want to boot up their service in isolation and be, hey, I need some data injected. Even demo scenarios would change as well, because demo scenarios right now use factory bots behind the scenes and tooling and call services. Now it's going to have to change to almost call like network calls. One, the service that has the model has to be up locally if you want to do that. And two, you now have to change what used to be Ruby API calls to network requests and go from there. So it'll change the landscape quite a bit.
Miguel, I appreciate that. I'm kind of curious about like, are there any approaches that you've already kind of experimented to try to help wrap your head around how you're going to make that happen? Or is there a couple different patterns you're kind of exploring at the moment that to kind of make that not so complicated to handle? I would imagine like you're going to have to rethink onboarding quite a bit for your new engineers with that, because like you have what 600 or 700 developers working on the application, like they're all going to have to rethink some stuff as well. That seems like a big rollout to kind of wrap your head around.
Yeah. Honestly, we're kind of flying the plane as we're building it and designing it at the same time. So it is a problem, and we're starting to see that. There was an introduction of Kafka into one of our core systems, which all of a sudden introduced a hard dependency in Kafka to be able to run locally. Because what would happen is before you didn't need to run Kafka because there was no core flow, but now it is in a state that like when I make a change to a model, we try to produce a message. And if you don't have a local broker set up, that will fail. So your local environment will fail now if you don't have that cluster. So our tooling is kind of catching up to some of the things that we are doing. There are patterns that we have tried in the past that did not work out too well. We have a list of what to avoid, but we're still trying to define the best approaches going forward, if that makes sense.
I think the simplest answer is be extremely sensitive about dependencies. So we now hold a really, really high bar for what is an acceptable dependency, either runtime or development or, background. Anything that we depend on, we don't run by default locally. So that forces us to think, what happens if it's down? And then we think, well, I can't run this feature if it's down. So that makes us think maybe we should build the feature slightly differently so the dependency is softer. So one example here is we have a super hardcore sensitive data store. We called it the hardened, I don't remember what the acronym stands for. We call it HAPPY. And this stores a lot of our most sensitive data, like social security numbers. And so the benefit of doing this is we have really hardened access controls, we log access and so forth. And then consumers of this just get an obfuscated key. This service didn't run for us locally for a long time in Hawaiian Ice on benefits. So we built all of our stuff to access this data and handle errors. So the way we did this, for example, in the front end, if you're looking at web UI and you want to see an employee's social security number, that would be a runtime dependency. So what we did is instead we show a padlock, and then you click the padlock, which makes a different HTTP request just to get the social security number. That gave us two advantages. One is we can authenticate separately. So instead of seeing, non-sensitive employee data, now we have to auth differently for sensitive employee data. But mostly what it meant is that when this service goes down or is inaccessible, it doesn't really stop anything in the application. It just means that you can't see that data. And then all of the writes that we make to this system now happen in background jobs. So if those jobs fail because the service is down, they get queued up. And then a few minutes later, when we fix that service being down, we can just retry the jobs. So that's maybe an obvious example, but that's the kind of behavior we're looking for anytime we have a dependency. We don't want it. So what can we do to avoid it?
Interesting. You're curious about that when you're sending, say you use that example of like maybe your happy system or you're storing more, your hardened data system, and you have a background job. How are you approaching encryption of that data in the temporary time between submission of a user into a thing, putting into a background job, and it's in this state before it gets put into this long-term storage place? What's that process look like?
You mean for writing specifically?
Yeah.
It depends on the context. A lot of the sensitive data we get on benefits is coming from the main monolith. So the source of truth is still there. So we wouldn't be told to write a copy of it unless we had the data there. And so we can always fetch it later to rewrite. Or if it's coming from a user, it's the same as that padlock. So if the user is uploading some sensitive data and happy is down, we tell that user, you can't upload this sensitive data right now. Try again in a few minutes. But again, we've isolated it just to that one thing, so they can still use the overwhelming majority of the app, but we can't avoid that dependency.
Yeah, I want to stress that that is something that Monolith HI has done, which is where Peter has done. Unfortunately, The main monolith was built with kind of like Rails first, that all the data will be there accessible at all times because we're a singular monolith. So one of the biggest things that we're going to have to evolve in the company is that we must build our UI now with the same principles that HI has done with that. We cannot guarantee anymore that all data will be there. And that is a culture shift that I think many engineers are going to have to get comfortable with, because our service might be tolerant to it, but the UI might not be. So from a user's endpoint, it says this isn't working, but in actuality, it's just that one piece that's not working.
The one sadness I have about Sorbet, and maybe Ruby more generally, is that you can't be explicit about what errors to expect. And so it really needs to be a cultural thing. If you're making an HTTP request, I think we're all pretty sensitive about if you make an HTTP request to some other service, you have to handle errors. But we're building these pseudo services using Packwerk. We still want to have that same idea. Anytime you lob data over the fence to a different pack, you have to handle, pretend there's latency. There's not, because it's in a Ruby process. Pretend there's no guarantee for a database transaction because it's in a different data store, and pretend that it might fail. So that's something that's really, really hard to do if it's all in the Ruby process. And if I'm here, the database is just fine because, so that's something that we're still building a muscle on. One thing we've done on benefits that I'm very proud of is we identified one of these pseudo services. And it goes back to the timing aspect of this, where we need a snapshot. And we built it using Packwerk inside of the monolith. And we did that because we didn't quite want to be guinea pigs of spinning up a new service that was depended on and so forth and so forth. But we did use a new database, because a new database would force us to have this sort of discipline. We can't depend on database transaction safety. We have to be sensitive about how we're writing data or making calls to write data. And then when we read it, if it's in a database, it's the same thing. We have to build in the eventual consistency Miguel's talked about a few times. If we write and then immediately read, the write may not have happened. So we have to build that. It's worked out really, really well at forcing us to think about like how rigid this boundary is. And because it's all in the same code base, we can iterate really, really quickly rather than thinking about versioning or like, what does this API, how do we evolve the API? It's all there in the same code base. And then the next step is move it to an engine. And then the step after that is move it to a different service and communicate over HTTP. But we're getting a lot of the benefits now all inside of the same code base.
Out of curiosity, what you mentioned the front end tooling. What does your front end tooling look like at Gusto?
Yeah, so we have essentially in the main application world, two major front ends. We have our administrative front end, which is essentially pure Rails. It uses active admin, and it is Rails paradigm.erb files.html. And then we have our customer facing one, which is React. Now, our front end is a timeline of different approaches. We have within it, you name it, we have HTTP requests, we have Redux, we have GraphQL. You can tell the age of a page by going into its code base and going like, what's it doing here? So
I think that's pretty common for a lot of teams to be out there. So I like that. It's like a timeline of, yeah.
So, but primarily the way that new products are built right now and new pages is that it is a single page application powered by React, and the interface to the backend is through GraphQL. We have TypeScript for type assurances within JavaScript, and it currently lives in the mono repo. However, that is also in the process of being split out to its own repo, which has its own sets of problems as well.
When you're kind of evaluating those maybe this is the purview of other departments, given that it's all in the mono repo, like, and you said it's going to potentially have other challenges to navigate if they're in different repositories. Are they able to work kind of independently on the SPAs? Or do you find that every time they're working on features, it's very, very tightly coupled to some, I'm air quoting, back-end development that also needs to happen? Or is GraphQL usually providing enough already? And then let the SPA get work done and it gets deployed and you just kind of work that stuff out?
We have set some rules in our CI/CD pipeline. One of the main ones is that we cannot guarantee that when you're making a GraphQL schema change that it will be there. So we do have a separate that you cannot commit GraphQL schema changes at the same time as UI changes because there could be a difference. But this is one of those cultural shifts that we were talking about. Many engineers feel that they must test the full flow of things before they feel comfortable that like, okay, this is working as intended. So they make their backend changes and they use the front end to validate that their backend changes are working. With this new world, we have to get into a mindset that you must be able to validate your backend changes in isolation within your service. And then, just test the boundaries at it, whether it be a contract test or something of that nature, so that you don't have to have the UI up and running and going like, okay, let me test this. If we stick with that, I think we're going to be in a lot of pain because then local development will become very tedious. You're going to have to find every service that you depend on for every page that you're navigating to. But if we can get away from that mindset and really see them as separate entities and be like, the backend is the backend, the UI is just a caller, then we're in a good spot to succeed here.
How does GraphQL affect the way you design those service boundaries?
I have maybe a spicy take here. I think that GraphQL being federated makes it really easy for user or implementers to not think too much about where to get the data, which is a big reason for it. I'm maybe an idealist or maybe too old school, but if we rewind about 5 minutes, I was talking about forcing people to think about error handling and eventual consistency, and GraphQL makes it so you don't need to do any of those things. I think this is something that we're going to learn as an org over the next couple of years, because right now, most of our data is coming from the monolith, or we're building benefit-specific pages and they're coming from a different monolith. But as we split things up, we're going to have to really think about, well, this page right now is depending on 5 different services. What if 3 of them are up and 2 are down? Or which combination can we tolerate? Right now, we don't need to think about that, it's good. It's helping us move really quickly, but slowly it's going to become hard. And we're not going to know, okay, well, if this service is down, this is the experience that I want. This is the degraded experience. Yeah, I don't think that opinion is super common at Gusto. I think Gusto is helping us go so quickly that the pros outweigh the cons. But I really think hard about these boundaries all the time, and I don't like that GraphQL obfuscates it.
Yeah, GraphQL, that is the benefit of GraphQL. The resolution of it is federated. So me as a caller, I don't need to know, I need to call service X, Y, and Z to get the data that I want. That is obscure to us. Where it becomes hard and we have to change our art here is that because you cannot guarantee what service resolves what, if one of those services are down, how do you handle that? Let's take that Social Security padlock scenario. Let's say I have a page that shows me the employee name, their Social Security, I don't know, birthday, and like a list of schedules. I know that my service can resolve the schedule, but let's say that in ZP that employee was actually deleted, and we never got the message that it was deleted, so we still have a reference to it. The front end passes that ID or whatever, we resolve it, but then when it goes and tries to resolve anything else, like name, birthday, whatever, it'll bomb out because that employee doesn't exist anymore and it could have been hard deleted instead of versioned out. So what is a degraded experience? That padlock strategy isn't going to work to like padlock the name, padlock. That's not how it goes. So we have to think about how your service might be tolerant, your backend might be fully tolerant, but how does it all come together in a way that if something is down, how does the page behave?
Those sound like some complicated things to wrap your head around and
It's
to
fun though.
disseminate across 600 engineers.
No, it is hard. I'll say it one more time. It all comes down to people problems or organization problems. A lot of this is we can either build something very simple where we can afford to be thoughtful about all of these things, or we can build something complex where we maybe can't afford to think about all of these things. And so I think as we're maturing as a company, we're getting much better at really simplifying things so we can be more fault tolerant and thoughtful about these things. So we're making a lot of progress and we're addressing those concerns, but it's hard.
For someone working on the, like, say, the React SPA, and they're trying to fetch a bunch of data, and like one of the systems is down, are they then needing to like try to handle all of that, those edge cases now in their code versus, is that the reality that are they, is the trade-off, I'm just kind of thinking like high level, I'm not pro or against GraphQL as an, or federated GraphQL in particular, is the illusion that it's just, this is, you don't have to think about it because you're just going to fetch stuff and it's going to go do all the work behind the scenes, bringing more complexity into just the front end code itself to handle all those scenarios in the fallback?
It is a transfer of responsibilities, I feel, because if you call my backend service with a REST controller and I had dependencies that I needed to fetch data from, I can inherit that risk, try to fetch it. And if one of those services are down, I now have to be tolerant to that in some capacity. So the burden lives on the service. With GraphQL, that I cannot guarantee anything from my service other than what I can provide. So now the burden is always on the caller to be as tolerant as possible when the thing that they're calling is down. Like a REST controller where I make a REST, I am the caller, so I have to be tolerant to when they go down, and I can be. But now the UI is a caller, and some of these pages are expansive. So I think we just have to rethink of how much data do we actually want to like load on a page? Because the more complex the page with different data points, the more the experience can get degraded if any of these things on it. So it just might be a rethinking of the UI.
Sounds complicated. Wrap your head around. Thanks for diving into that for us. I'm going to do some pondering myself after we get off our conversation later about how I'm thinking about things on my end as well. Miguel, one of the things you said in our prep call is you describe Rails like a Formula One car, fast but tricky with too much weight. How has Rails helped you succeed, and where has it shown its limits at scale?
So the analogy I was using is that Rails is a Formula One. So there's no baggage to it, meaning you're a lightweight product or something like that. You can go really quickly, and it allows developers to just go. But there's not a lot of securities in Formula One cars either. There's no airbags. There's no, you have a small cage and stuff like that. But it's really up to the driver, in this case, the coder, to really know how to control this car well and to follow the guidelines just so that if something does happen, they don't blow up and crash. When your app increases in size and complexity, consider that putting weight on the Formula One. So now the speed is being weighed down by all this complexity, and maneuverability becomes much more difficult because now when you turn, you might be shifting a bunch of stuff that you before didn't care about. So now you have to control how fast you're going, and you have to be much more cognizant of if you make a pivot somewhere, what are the consequences of that? And that's why the extraction work is at play here, is because we're trying to get back to that Formula One, get rid of the weights, and just have a very lean service so that you can once again feel comfortable going at speeds that you were previously achieving.
This isn't super related to the metaphor, but it was a real turning point for me when we were talking about breaking up the Rails application, the monolith. We, for a long time, thought about how a certain service owned certain things, data, functionality, and so forth. That went reasonably far, but the turning point was when I realized it was more what the surface area is and the interface between services. So how we're sharing those things. And then you start to think, if you think from that perspective, Rails has a very large surface area for almost everything. And this allows you to go really fast because there is an API for the thing that you want to do, I promise. We talked before, an active record model has several hundred APIs. But if all I want to expose is an attribute reader for one column, I have to do more work to lock the rest of that down. And so in a similar way, the F1 is all of the APIs are there. Everything that you could possibly need is there. But that safety Miguel was talking about, how it's lacking, is, well, I have to support all several hundred of those APIs now. Whereas if we invert that a little bit, make everything private by default, now I'm exposing only what I need. And when we extract all these services, we get that boundary. It sounds obvious, but that boundary is there because the only things that I'm exposing are available over HTTP or GraphQL or whatever. But all of those other APIs, you can't access them if you tried.
One of the things you mentioned earlier was around developers. Right now, like if someone's working on some features or some things in the back, I'm air quoting back end, and needing to maybe feel like they need to go click around in the web views to make sure things are still working there. How does your team think about testing? What sort of tooling do you have in place? Do you have a lot of end-to-end tests, or is that kind of more on the SPA side of their responsibility? Are the backend developers running those tests on a regular basis, or where's that kind of those lines? Is it blurry, or is everybody be able to run the whole test suite locally, or
we have
do you have a test suite?
We have better test coverage than any other company I've worked at, but most of that coverage is at the unit level or at the very high level integration test. And the high level integration tests generally test happy path cases. So we get the edge cases through unit tests, and this works pretty well for us, but we could still improve. And I think the best way to do this is to make the problem smaller. So if we can define those boundaries better, then there are fewer cases that we need to support because we've identified what works and what doesn't. And then whether we call it a unit test or an integration test, kind of it fades away. Miguel, you work in a much bigger application. I'm curious to hear what you think.
So we have essentially 3 levels of testing. We have the unit testing, the integration testing, and then a full end-to-end where we actually boot up a headless browser and navigate from the front end. Unit testings we're primarily using them for edge cases, and like happy paths, make sure that the function works. Integration testing tests our GraphQL layer primarily to make sure that when you hit one of our GraphQL layers, our services are called and everything resolves. And then end-to-end is just, smoke test, or some teams use it as a better assurance of an edge case that they found and they want to test with an end-to-end. But all of this is going to change in extraction because a lot of these tests are built with the assumption that you're in a monolith, because some of these use factory bots to build up applications. Well, in my service, I may not have access. I won't have access to your factory bots. A lot of the integration tests have to be thought differently. Unit tests remain the same. That's all mocked for the most part. But integration tests, and particularly end-to-end, how do you run end-to-end in a distributed system? Do you bring them all up and then you run them? What does that mean for local development if I want to run an end-to-end test locally? So that is being thought out of right now, and we're going through these problems to try to find out what does the future state of our testing suite look like.
That's another fun challenge. It sounds like you folks are wrapping your head around, and maybe we'll have to have a follow-up conversation in a few years and see what you learned from that. Are there any areas of the code base in the monolith that kind of nobody wants to touch?
Those are my favorite places. Those are the juiciest ones. There was a time a few years ago where we had to work on an integration with a third party, and the integration was built very quickly and maybe not in the best way. And that was one of the most fun projects for me to work on. I used to joke it was like walking around in an apple orchard with so many apples that you couldn't take a step without one whacking you in the face. There was so much low-hanging fruit, so much room for opportunity. Anyway, but of course, there are parts of the code that are brittle. And if you look at it, you think, I can't believe this is working, but it's been working just fine for 10 years. And so you just kind of let it be, respect the legacy code.
When I joined, we've gotten much better at this now, but when I first joined, one of the things that I found that was pretty hard to engineer was with, you had teams that own code, but that was on paper. What it actually was, you had that one engineer that worked on it that was the true owner of the code.
Mm,
And if that person is gone, the
yeah.
team might say, yeah, we're the owners, but as much
Mm.
as we do about it. So we've gotten better, and time has really, like, we're really invested in documentation such that anyone can be an owner. Even if you just come into the team and know nothing about that, we can onboard you with a list of diagrams and explanations, so you don't have to splunk through the code and get at least a high level understanding of what does this do. And then that way the team truly owns a domain instead of just the individual that happened to work on it.
It's helpful to get a perspective on how teams think about that. And it always does seem to come back down to like, there's that one person. Can we wait till they're back from vacation next week before we have to touch it, please? Uh, do you use any other like tooling to help you identify like high churn areas or things that just, is there team members there? Like, do you have like a platform team type of thing where someone that's responsible for thinking about the developer experience and always optimizing that? I've talked to some teams that at a larger scales that have that, say, luxury to have people that are focused on those things, thinking about upgrades, and they're the ones kind of tackling those things, or is those kind of like just shared responsibilities across the wider engineering organization?
We have dedicated teams for a lot of that stuff. We also send out a survey, I think once a quarter, to just get a feel for how engineers are feeling. Is CI, does it feel fast? Could it be faster? Is code easy to understand if you don't work in it regularly? How's documentation? And so we can see how things trend over time, which is pretty valuable to identify hotspots. And then we break it down by team. So you can see, well, this team thinks that CI/CD is really slow, and that team thinks it's really fast. So, it brings a lot to the surface. But we do have teams dedicated to a lot of the foundation stuff, and then within the teams, yeah, we talk about that stuff a lot.
The overarching, we do have platform teams that like, we have a UI that lets you run scripts against it. It gives you ownership, tells you who owns what and who owns
Mhm.
where. And we have these, I guess, surveys, as Peter mentioned. But there's also the responsibility of the teams to make sure that their code is, their domain is, well maintained and well documented. So you can have wide differences in our repositories, because that ground level responsibility is still on a team by team basis.
It's one of the challenges that we have, because as we've gotten better at identifying these pseudo services, some pseudo service. So by pseudo service, I mean a thing that would ideally be a remote service, but is now just the boundary is with Packwerk. Some are really clear, and they've had the time and resources to invest in their APIs. So their feeling of the application is very different than a team that's inherited very legacy code, or maybe more dependent on the other monolith. So experience from team to team is largely dependent on what that team is responsible for. And so that's kind of difficult, because we try to draw conclusions like we need better documentation. Well, half the teams think that their code is better documentation than a document would be, because the APIs are well defined and we've got Sorbet strict signatures across the board. Everything else is private. But then some other team is looking at 10-year-old code that makes no sense to anybody. And so they have to depend on documents explaining, like, this is what you don't touch. This is how this works at the big picture. These are the things that we haven't quite been able to fix, but don't need to be fixed quite yet. It varies so much because it's such a big application.
I can appreciate that. You were just mentioning those quarterly surveys. There's like developer experience type surveys. I don't know what types of tools you're using there, but and we've used those types of tools as well. And it always feels like, even at our scale of like a engineering team of 15 people or so, it's always feels like, well, it's very contextual off of the types of projects the team's working on at this point in time. and we're working on different clients even. So it's like when you're in that scale, like it's like you're tracking sentiment, so some subjective, it's kind of like a snapshot in time of how people are feeling about the code, their test coverage, documentation. And then there's a lot of like, well, we can't just draw a conclusion across the whole organization because of this. So there's a lot of context there. Are you able to then align that with any objective data points? Like our test suite has actually gotten a lot slower over the last quarter. So this seems to be aligning, or actually we can actually say the test suite is actually a lot faster than it was 2 quarters ago, but the team still feels like it's super slow. Is this a team human communication process? Like, hey, we're not celebrating the wins enough. We're not talking about the positive progress that we're making at 600 people or plus. I can't remember the exact number there. That sounds like a challenging thing just to kind of like get momentum and energy and excitement about when we're all working in our own little silos in different parts of the organization. And
let's see. So we do have a lot of objective data around code throughput, cyclomatic complexity of diffs, breakdown by engineer even. So we can see, again, big picture trends. The problem with a lot of this data is it can be explained away in many cases. But another thing we've done in the last 2 or so years is lean very heavily into visibility through Datadog. So not only do we use Datadog for performance of the application, but our foundation teams will even use it for things like understanding CI/CD or deploy frequency and so forth. So we build service level objectives, SLOs, both for like a product team like I'm on is responsible for endpoints take less than a few hundred milliseconds, error rates need to be less than this, whatever. But our foundation teams will say, this process needs to take less than 10 minutes, or those sentiment surveys need to be trending up instead of down. So we really believe a lot in that because big picture, that tells a much more detailed story over time.
what's something that your team does differently from most Rails teams you've met, Miguel?
I think, at least within Gusto, the structure of our services is generally what many people would consider to be non-Rayleigh, which is the services to repository to, because one of the things that our team does that when someone modifies our code is that they put a lot of logic on the model, because it's that mentality of, I cannot guarantee that someone's not going to call my model out of the blue. And I need to have that guarantee that if you do something, we have validation at the model. Where our team comes that does differently is like, no, the model may have some basic validations, or something that, like just validate the presence of this and true, but no complex thing. And we are very adamant that the only way that you interact with it is through our services. So our models are actually protected classes that if anyone modifies them, you need a review from us. And we take on that risk. It's like Peter says, we cannot guarantee privacy, but we are very adamant that we will follow that service repository structure and, rely on Sorbet and Packwerk to analyze, is someone doing something that they're not supposed to in the monolith? And once we get away from the monolith, that might change, because now anything that we do is within the service, itself, and privacy is inherited by nature of not being in the same namespace as everyone else.
Peter, anything on your end that comes to mind, maybe less technical?
I don't know exactly, but I think there are a few things that Rails likes that we don't do. We pretty much forbid metaprogramming, or at least that we write. So the metaprogramming that there is tucked away in gems with really clear APIs. Like I mentioned before, we try to make all of our active record models private. So we kind of harness power, but we hide it and we protect ourselves from that. Yeah, we lean a lot on Packwerk and Sorbet. I think one thing that is really powerful about Rails, maybe this is just a different way to say what I said before, but there's a lot of functionality kind of tucked away and implicit with things that we're doing or things that we can do. And I think the number one thing that we try to do or try to include with every single thing we do is make it explicit. So anytime there's a dependency, we want to scream from the mountaintops, this is a dependency. We don't want to hide it. again, I'll bring up the active record models being private. It's very, very powerful to have an API that says explicitly, this is what is happening. This is what we're using. This is what we're depending on. And then all of those other things that you get, ideally, we lock them away. And if we need to bring it to the surface, we can very easily. But the hidden functionality at our scale becomes very, very difficult to control. And so we want to make it all explicit.
I can appreciate that. I want to thank you both for coming on Rails today to talk shop with us. A couple of last questions for you. Is there a programming book that you find yourself recommending to teammates or peers again and again?
No. the closest thing is Ruby is not my first language, and I used Ruby cones years ago, and that was probably the most valuable learning tool I've ever used for programming. But the way that I learn is by messing around with stuff and seeing what happens, and thinking a lot. And so I don't, unfortunately, have a book that I'd recommend. I think the best way to learn, for me at least, is build stuff, see what breaks, fix it, learn from it, and just accumulate all of those little details over the years.
Sure, sure. What about you, Miguel?
The only book I recommend when it comes to programming is Cracking the Coding Interview, because once you get into the door of a company, you learn much, much more being on the ground than I feel any book can give you. Books give you theory and ideas, but they cannot replicate, the real life scenarios and the day-to-day that working at a company does. I recommend that book. Get yourself through the door, and then you really learn the intricacies of engineering.
Another thing, too, is reading source code. I love digging through Rails. I work a lot in iOS, too, so you can't see the source code there, but understanding how those things work and digging really deep into it has taught me patterns in a much more intuitive way than reading a book would, because I can see how it's working and I can play with it and I can touch it and feel it. I love reading source code.
It's a fun hobby for some of us, right? And where can folks follow does Gusto have an engineering blog that I can link people to, or?
There's definitely an engineering blog. The URL escapes me right now, but check out gusto.com. It's there.
Well, I'll definitely include links for the engineering blog and in the show notes for all of our listeners. And with that, it's been such a delight, Miguel and Peter. Thank you so much for stopping by to talk shop with us on Rails. Really appreciate you taking the time with us.
Thank you so much. This was a lot of fun.
Yeah, likewise. Thank you very much for having us.
That's it for this episode of On Rails. This podcast is produced by the Rails Foundation with support from its core and contributing members. If you enjoyed the ride, leave a quick review on Apple Podcasts, Spotify, or YouTube. It helps more folks find the show. Again, I'm Robby Russell. Thanks for riding along. See you next time.